All right, well, my name is Zach Semke again. I'm Director of Passive House Accelerator. It's really great to have you here. We are super excited for today's program, Achieving Thermal Performance in Modular CLT Developments. And I want to thank our co-creators of this show, the Building Performance Interactive, Hugh Wierisky of Partel and Yulia Potor of Partel. And Yulia, I'd like to invite you to say some hello.
Thanks, Zach. Hi, everyone. I'm Yulia Potor, Marketing Manager of Partel. I'm looking forward to seeing today's presentation. I think it's a fantastic project, so I'm keen to find out more about new approaches from Northern Europe.
So I'm really happy to be joined by the co-hosts of Building Performance Interactive, Hugh Wierisky of Partel, Mike Jacob of Kiss House, and Ben Adam Smith of House Planning Help. So with that, co-host, can you take it away?
Yeah, thank you very much, Zach. And it's great to be back on another one of these calls. I'm particularly interested about this because I always see myself later down the line retiring in a co-housing development. So I know there's a ton of work involved normally in these projects, full stop. And this one looking particularly sustainable. Funnily enough, I've been working on a podcast this week about CLT. So I feel very clued up and prepped for today's call. And I'm going to hand you over to Mike now.
Hi, everybody. Mike Jacob, co-founder of Kiss House. I'm delighted to be here. In the run-through yesterday, Martin, who's going to introduce himself in a minute, said about the projects, there's just a feeling you get inside. You can't put it into words, you just have to feel it. And that really spoke to me. There's a lot of intangible wonder and mystery about buildings that more often than not just doesn't get addressed. So I'm really looking forward to hearing about this. Thanks.
Yeah, thanks, Mike. Thanks, everyone, for joining. My name is Hugh Wierisky. I'm a director at Partel and pretty much can echo the other comments. And we get a little sneak preview to the project behind Martin. And yeah, I think it is everything they say it is. So yeah, delighted to welcome our two guests today. First is Morten Kudahl. Morten is a product manager at Kliima. They're a Danish supplier of high performance building envelope systems. Morten and the team at Kliima are solution-oriented suppliers, and they also provide a great deal of support and actual training for tradespersons. And I can say Morten personally is one of the most knowledgeable professionals I've encountered in this space. Really, really strong technical and practical understandings of everything related to airtightness, weather, sealing, and insulation. Martin Wagner is the head of marketing and communications of Tetris Real Estate Development based in Copenhagen. Through his experience as a senior strategic and creative consultant, Martin has brought a different and fresh approach to real estate development from when he joined Tetris in 2018. Tetris began development of the Agora Gardens based on customer insight in 2018, and now have 3 developments running, and I think 5 more on the way. So yeah, Martin's going to introduce us to the project with some technical insights afterwards from Morten. So over to you, Martin.
Thank you. I'm so proud to be invited to this one. But as you said in the beginning, it's all about the feelings, and feelings are better showed in a video. So I will run a little video, and I'm sorry, but it's in Danish, but I'll explain afterwards.
Design Award er en international pris, der gives til verdens bedste projekter inden for designarkitektur. I år er vi hos Tetris, som den eneste danske ejendomsudvikler, nomineret for vores boligfællesskabskoncept Agorahaverne. Og det er vi selvfølgelig stolte af. For det viser nemlig, at vi lykkes med at skabe et banebrydende alternativ til parcelhuset for de voksne over 50 år, der ønsker at bo, hvor privatliv og fællesskab er tænkt sammen på en helt ny måde. Alle beboere har deres egen private bolig. Og så har vi skabt det her fantastiske fællesrum, den store overdækkede atriumhave, hvor fællesskabet kan spire og trives stort set hele året. Så hvad siger du? Det er da sådan et sted, man har lyst til at bo. Og det er også derfor, at Agorahaverne er nomineret til dette års Design Award.
So basically what I said on the on the screen or on the little film there was that we were nominated to the Decina Award last year. And we actually won. We won in the category of housing projects. We won the public award. So I'm pretty proud of that. And an award is actually not an achievement in itself. The achievement in itself is that when people live there and we can see an improved quality of life. And that we can. I think I'll start with what is Agorahaverne. Our journey started with, we wanted to build a sustainable housing community for teenagers built on research and values. And this is a very compressed statement, so I think I'll break it down a little bit. A sustainable housing community, that kind of is self-explanatory. Teenagers, we have called our target group that because they are 50 plus. They don't have children living at home anymore. And most of them are living in their own house. They are perhaps in the end of their working career. And they are thinking, why are we living in this big house, only one or two persons? So that's a question they ask themselves. And a question that we reflected upon in the last part of the sentence, built on research and values. Because we did extensive research when we first designed the Agora Gardens. When you're in the late part of your work life, what kind of housing needs do you have? What kind of community needs do you have? And what kind of values do you have? What will you value in the next place that you live? In Denmark, we have a really big gap between the family home and the nursing home. There's a really big gap there. There hasn't really been any kind of developers going that direction saying, maybe we could tap into this. So we tried that. And we tried, one of the things that we said that a core value for many of these persons when we asked them was we wanted more freedom. But what is more freedom? We interpreted more freedom into one thing, and a couple of things actually more, but one thing that was less space, because we wanted to create a private home that was relatively compact, because if you have a relatively compact home, you are more prone to live your life in the common areas. I'll get back to that. So we created rather small houses, which is also more sustainable. And here it is. This is the heart of the Agora Gardens, the big atrium garden. This is where the plants and the community grows together. And we wanted to create this very special room where people could actually meet and where they strive to go. So one of the things that we also asked ourselves is, how do we as a developer create a community? The very short answer to that question is we don't. But we can create a building that in its design supports community. And we can create an opportunity to be either private or be together. Because we know that community living is about doing things together. We wanted to target a group that is normally targeted in this kind of housing projects, which is the men. Single men in particular have a high risk of being loneliness. And if you end up in loneliness, that you're prone to have a very decreased quality of life. So we wanted to come up with a concept that was also appealing to the men. In order to build a community, you have to have a common project. And one of the things that we kicked in or looked into was the size of the housing community. It has to be a certain size. Not too big, not too small, but what are the magic numbers here? So we visited Robin Dunbar, the Dunbar numbers, saying that you can have no more than 150 close social relations. So of course we had to build it at less than 150 inhabitants, but we also have to build it big enough for people to actually have communities within the big community. Because community is a choice, and so is privacy. So we have created small, compact, personal privacy cells, not cells, but apartments. And then we've created the big atrium garden where people can actually meet. Now, yeah, there we go. Here you can see how the layout, this is a general layout, and I've just fastly translated. You have the common room, which is down at number 1, where you can have a gathering of up to 30 people. And the reason why we haven't made that one bigger is because if you are a bigger gathering, you lose the intimacy. And it's not supposed to that everybody should meet everybody every night. That's not the whole idea. The whole idea is that you can have small communities within the big community. And when you have a compact apartment, one thing you lack is a guest room. You don't use it very often, but when you need it, you need it. So therefore we have a common guest room. The interactive board I'm not going to skip, but then we have the Agora. And that is actually the big wide open space where you can gather more than 30. You can have standing gatherings if you want to gather the whole community or part of the whole community, or you can have sitting gatherings where you can have guests, for instance. And then we have different zones, like the reflection zones, like the lounge area, like the activity zones, and like the kitchen garden. Because the common area also has to be a place where you do something. You grow your own herbs. You have the bull lane where you can play bull. And then you have the different areas where the inhabitants are actually taking care of the community. So we don't create the community, but we facilitate it by the building design. So, and if you have any questions regarding the Agora Gardens in general, please write them in the chat because we'll do it, we're doing Q&A session later. So back to the layout. What we have done is that we have created, as I said, different zones because we need to have small communities within the big community. And one thing that we can see is that when we ask our inhabitants, they are very, very pleased with the big with the atrium garden. One of the inhabitants that I interviewed 2 weeks ago, she was like, "This is like nothing I've ever experienced before," and I have to concur with her. It's absolutely amazing what we've done. So this is very general about the concept, about our thoughts, reflections on what we have. So that was this for me for now.
All right, Morten, will you take it away, please?
You're still on mute, Morten, or is it the video, Zach, that you...
Yeah, Morten, Morten, would you like me just to go straight into the video?
You need to, yeah, so okay. You unmuted me, thank you. Okay, thanks a lot. And I guess from the introduction Hugh gave me, then I can only fail from here. But okay, so what Martin's already told us a lot about the project, and now I want to show you how the prefab modules are being built. So we've visited the prefab producer FlexModul here in Denmark. Where we've met, you'll see Brian, he's the technical director of FlexModul, and we'll go through the production and yeah, show you how things are done. And then afterwards, we'll as well visit the finished project Ibihaven. So enjoy. Today we are here in Slagelse visiting the project Ibihaven, which is part of the bigger project that's called Agorahaverne. Haverne means gardens. As you can see, this is somehow an inside atrium garden. Or this project was built in 2020, so the people here has been here for 2 winters now and had some different experiences with warm summers, a bit cold winters out here. But inside the different apartments, they are of course built as we do in Denmark. When you build and calculate in your energy consumption calculation, if you follow the standard and you build to 1.0, then you need to test. If you build to do the blower door test, if you build at 0.7, you need to test. If you don't test, you need to calculate at 1.5 instead of 1.0 or 0.7. And no matter what, you still need to comply. So even though you use in the calculation 1.5, which is kind of a penalty, so you need to do something else with insulation and so on, you need to reach the level 1.0. So in this project, we have plus 150 apartments, and every apartment is tested individually and reach the 0.7. Regarding the insulation level, we have a quite strict standard here in Denmark. So we have the U values that are quite low. If we look at the walls, we're at 0.12. If we're at the flat roof, as this construction, we're at 0.08. And if we are talking about ground level at the floors, we're at 1.0. So the total energy consumption in such an apartment is very low. Because of the incredibly low energy consumption, it's possible here to heat the dwellings only by the ventilation system with an additional heating coil. Another thing is, in this project, they've installed PV on all the flat roofs, and the residents can follow the energy consumption in real time on a screen. So yeah, all the time they can see what is being used, what is being produced by the PV. And as you saw earlier, FlexModul are building these modules, prefabs in the factory. But they don't only build them, they also do the installation here on site. So because of the prefabs are more or less 90 to 95 finished from the factory, it makes it very efficient also when installing. So they can actually install up to 20 modules a day. And again, it's very efficient and again, very, I don't know if we can call it a clean installation, but safe, because in the factory, the elements are being wrapped in plastic and they drive them to the building site, install them, and then remove the wrapping just before putting the second floor or second and third floor on the ground floor. So you'd have no problems with rain coming down and so on. It's a very dry installation as well.
Welcome to FlexModul. My name is Brian. I'm CTO here in FlexModul in Vinderup. We are producing prefabbed models and using timber for the most of the time. You're here in our new production line where we have increased our capacity to 500 to 600 models per year, and we'll be ready per 1st June this year. I've been working with models for 10 to 15 years now, and I started here in FlexModul in 2017. and we start our first line production in 2019, and we have been increasing the production ever since. We are expanding our production of prefab models because we're seeing the market is going up, and we are experiencing our customers having bigger and bigger and larger projects. We see a lot of projects at the time is going to apartments. It's a big trend to be doing this with the woods, and if you're doing in an environment like this, it's controlled and there's a big quality and with a lot of standardization. We have a customer in Copenhagen, and together we are producing thousands apartments over the next 5 years. The sizes for the projects is from 15 to 18 apartments. And this is called Agorahaverne. We are not so much cheaper anymore as we started the journey, but we are faster. So we are producing the models as you are on the construction site and doing the concretes. So we are faster today than normal or traditional construction. We are about 20% more efficient than if you're doing it traditional. It's definitely increasing, and the trend is going up. Kliima is a professional partner for FlexModul and has a lot of knowledge according to air tightness and to the products and to the solutions for.
We are in the production facility here at FlexModul. This is the place where roof elements are being made. Right here, they're ready to install the Vara Plus intelligent vapor barrier. The guys here are very good at their job, but also keen on doing a good job. Very focused on doing this layer airtight. First of all, you'll see that they only have 2 joints on the whole element. They only use staples out here, and every place where they have a staple, they afterward cover it with wooden construction. This is a flat roof construction. In this project, it's non-ventilated construction, and that's why they're using the intelligent membrane. In general, you could consider that a flat roof would be more critical than a pitch ventilated roof, but taking them inside, building them very dry from the beginning, we make them very safe, and since the quality here at FlexModul is so high, you would also know from the beginning that the element itself is very, very airtight. Yeah, now we're in the production line. Earlier we saw the production of roof elements, floor elements, and we'll see, I guess, the wall elements as well. But this is the production line. Right now, they haven't started the assembly of floor and walls, but this is the first station where the elements are put together, and we'll go through the line and see what they're doing on the different stations. But this station is assembly of floor, walls, and roof. And this is actually also the place where where focus also is air tightening. The first station where the floor, walls, and roof is assembled. Then we've got the next stations where they insulate from the outside, start working on the inside. Then a couple of steps down, we've got they're starting doing the walls from the inside with plaster. At the different stations, as I said, they start insulating from the outside, then start working on the inside as well. Then they put on a membrane from the outside. Same time on the inside, they're doing skim plaster. Next station, starting doing the painting. Then we go a bit further down. They start putting in the kitchen. Actually, in this station, they also put in the bathroom pot. When we come to the forest, then we see that they have already installed boards on the outside, and then they install windows, doors. So we're here in an almost finished module, actually already wrapped from the outside. But what we can see here, apart from it being almost done, is that, or what we actually can see is the heating system. We've got no floor heating, or instead we've got an, you can't see it inside, but it's an air-to-air system. So the whole module is only heated by air-to-air. And then again, we've got, maybe you can't see it, but over here we've got a small radiator, because in Denmark we've got rules that you need to have, you need to be able to turn the heat up and down in each single room. So even though it might not ever be used, we've got a small electrical radiator over here. Again, what we've been talking about with air tightness, we've been working with air tightness in Denmark for many years. Back in 2006, it was introduced that the air tightness should be no more than 1.5. Later on, we had different building classes, so it should be more and more airtight. A few years ago it was changed, so the maximum is 1.0. In this project we're at 0.0, which is in the calculation for the total consumption of energy to heat and ventilate and so on and so on. So they need to reach the 0.7 here to address the rules or the standards. Good. Okay, so I've can you see it?
Yes.
Good. So I've made a small PowerPoint presentation as well. I guess in the heat of the moment, a couple of things were said that wasn't totally correct, but I'll try to do my best. I'll just talk a bit about the Danish building code, a bit about how the air tightness is done in a project like this, and show a couple of pictures as well. So in the Danish building code, we have this energy framework. The energy framework tells you, as it said here, the total consumption for heating, cooling, ventilation, and domestic hot water. As I also mentioned in the video, we've had some different classes the last 15 years. Right now we're at either you have a standard class, or you can go to low energy house. The standard is what you need to do. You need to address the rules here, and then you can choose for yourself if you want to go lower. But if we have a standard house, Now, this is just an example, 150 square meters, but the standard just says that for your total consumption, you can use 30 kilowatt hours per square meter, plus these thousands divided by the heated floor area. So you'd in total in the 150 square meter house, you'd have these 5,500 kilowatt hours for the total consumption per year. Then if you go to your low energy house, then as you can see, you just have the 27. No additional anything, just 27. So you're at these 4,000 kilowatt hours per year. And this is what you need to reach. So it's not like you can totally decide how to reach it, but this is the energy framework. So what I'm showing you here is not the minimum thicknesses of insulation in the building, but this is where you need to, let's say, start. This would be a normal house in Denmark to reach the energy frame. So you can see you'd have a U value in the roof of the 0.1, the wall 0.14, and as I made a mistake for sure there in the video where I said 0.1, but we're at sorry, at 1.0, but we are at 0.1. This is a standard house. Then if we go to a low energy house, you'd be looking at these values, 0.08 in the roof. At the floor, we are at the same level. Walls are a bit lower as well. And then again, if you want less insulation in the wall, you could put more on the roof or vice versa. In the specific project like Ibihaven, you'd be looking at these values. This is what they've realized. So at 0.09 in the roof, again, we've got a bit thinner wall, so we're at 0.15. And when you go to the floor, then you're at 0.06. In the video, I talked as well about how to heat these apartments. It is a combined system. So you have ventilation, where you've also got your kitchen hood included. And as I said in the video, you'd have this extra heating coil for your peaks or lows, so to speak, in the winter when it's really cold. Then you'd need a little more. You'd need a little more heat, so that's where you got the extra coil. It's a quite big system for a small apartment, but again, this is getting more and more standard in all these projects. And as you see, it's a very efficient system where you got up to an efficiency of 95%. Also talking about air tightness. As mentioned, when we do our blow door test, then in the standard house, we'll be at 1.0. And then according to the building code, 10% of all new buildings should be tested. As I also mentioned, if you don't want to have or if you don't choose to have your building tested, then you need to calculate it with 1.5. So this makes almost everyone having their building tested, so they can calculate with 1.0. And again, if you go to a low energy house, then you're at 0.7, and everything needs to be tested. So as I mentioned, all the apartments in the Ibihaven was tested. Yeah, so we're here at back at FlexModul, looking at this roof element. As I mentioned as well, this is the element that where you really need to be sure that you're doing a good job making it airtight. So as I've tried to show you, this is the only penetrations we have by stables here, here, and over to the right. On the edges, you'd have to afterwards be connected to the wall sections. So you'd have a connection here that would cover the stables. Here the stables are also covered by the tape. So actually the only penetrations we have is by the nails. And again, of course we've got a lot of nails, but this connection is totally airtight. When we have penetrations of pipes and so on, I think this is the next slide. I haven't been able to show it to you in the roof element, but yeah, we've got a slide here. All the installations will be done beneath the airtight layer. So you've got no penetrations here. As you can see, there's this installation layer. So again, a very safe construction. So now, as I said, this is not the roof element, but here we're at floor level. This is done on the building site, where we use grommets, or this is a 1K liquid applied sealant. If you look here, every time we have a penetration, we do grommets of some kind. This is a picture that shows you where all the installations come into the module. And then we will have the connection from the airtight layer, as you see the blue layer here. Then we fix or install the module, and afterwards, in this situation, you can see the vapor barrier coming from the wall, and then will be connected to the airtight layer beneath. So I've just got a couple of pictures from, this is actually not the Ibihaven, this is the current project called Sofushaven, also in Slagelse. Again, it's the installation of the modules, but also I visited this site the other day to see how the people the craftsmen are working with the air tightness, and we've been looking at different solutions to make the buildings even more airtight. So as I mentioned, clean installation, of course, these days, the weather's very good, no water coming down or anything, but just to show you how fast it's, I guess you can see, but this is the same day. So at the end, they had these 12 modules installed. Over to you, Hugh.
Yeah. Thanks, Morten and Martin, for, I guess, you're both equally detailed and really interesting insights into your respective areas. So I guess I'm more used to the air tightness, but Martin, it's certainly interesting to see the process of how things came together. And I guess when I saw and heard about the project, and I was lucky enough to see it and experience it as well, and I can agree with everything that's been said. It feels fantastic when you step into the atrium. I love the term teenagers. Again, it fits and makes sense, and you can see it, and clear that it's kind of a missing link. You know, we've got like you say, a gap kind of between care and that time where we really don't need that large house. On the project itself, I love the efficient use of CLT, so not full wall panels, only what's needed. And overall, kind of, there's not many people doing what FlexModul and Tetris are doing, I guess. It's absolutely possible to finish houses to that level in the factory. And when I see the factory and each station has the materials it's used right beside it, it's perfect and logical. But yeah, it all looks uncomplicated. And that's the aim, for it to look and be uncomplicated in a way. And when you go to a construction site where everything looks complicated, there's generally mistakes and issues. So, you know, a huge kind of hats off to you for that. And on the end, the project itself, you know, it's super sustainable and really an example in lots of ways. From speaking with you, Morten, the base standard for air tightness insulation, I had to let you know that that isn't normal. So to try and encourage you to talk about it, because yeah, you're so used to it, and it's lovely to see that it becomes a standard and everyone just does it and gets on with it, and it's just the building regs. So, you know, no real reason for people not to do that in the future. So yeah, just go with it. So
yeah.
Yeah.
And it's got nothing to do with the fact that Rockwool is a Danish company, but I mean, I wouldn't say that we have had more strict rules, but 10 years ago we were actually working with thicker walls and roofs than we are now. We've been seeing roofs with more than 600 millimeter insulation, and yeah, maybe even 1 meter. So we're at more normal levels now, but still building very with very low U values. Yeah.
Not completely perfect, but always there. So what do you think, Ben, yourself?
Yeah, I'm going to start on that because I like the comparison between the building code and the low energy home. And I was thinking, are these virtually exactly the same? You know, so it just goes to show this is why we should feature more from places like Denmark, because we should be doing this too, shouldn't we? Having targets like that are obviously so commonplace. The one thing I did think was strange is that on the building code side, they didn't test the air tightness of all the buildings. You'd think if you're going for an air tightness of 1, well, you really do need to test all of them. But I think that's what was said anyway. But yeah, just going back to all those things that seem to be so right, you know, the precision that you get in the factory, some of those shots there, you can see how well packed all the insulation was, just that it's going to be fast on site. Lovely project as well. I'm intrigued though by the design, having that central bit covered. So that is something that I'd like to expand on a bit, particularly with so much glazing above you. So whose decision was that? Perhaps we could find out. Martin and Morten going to pick up on that, or shall I?
Yeah. Yeah, I'll pick up on that when I can unmute my microphone.
Fair enough.
Yeah, it was our decision. We wanted to create a very, very light space, but we wanted to create a shield from the Danish weather. And having that said, we cannot heat it because that will be totally unsustainable. So therefore we have to just sort of like an unheated greenhouse. And we don't use glass. Back to the sustainability agenda, glass isn't the most sustainable building material. So we use a kind of plastic instead. And another note on plastic and sustainability is that we usually, when we do the concrete foundation, we use steel bars for reinforcement. In Agorahaverne, we don't use steel, we use plastic fibers. So we can actually take the concrete, if we should demolish the whole building, we can strip everything and we can reuse all the building materials, or more or less all the building materials.
Yeah, but it certainly does look exactly the sort of place that I would like to go. I was listening to the story about the teenagers and thinking I one day could find myself in a very similar position. So we just need to get a move on here in the UK. I've visited a couple of co-housing sites in Lancaster and also in Cambridge, and yeah, I'm completely sold on the idea. Mike, what do you think?
Yeah, thank you, Morten. Martin, very inspiring. I love the fact that you, as a real estate developer, are so progressive and are doing the amount of research that you're clearly doing, and undertaking these kind of projects based on consumer insights. Whereas, in contrast, here we tend to find the emphasis is on profits and places to sit down and watch TV, and that's kind of the norm. So to see this atrium space. And as you said, the community is something you can't create, that will create it itself, but you're facilitating a community, a potential community. And I'd just love to be a fly on the wall and see what happens as the days and the months and the years unfold with the petanque pitch and the areas for congregating and the kind of the space to exist within. But what actually happens in that space would be amazing to learn more about as it evolves. But what an amazing project. And just coming back to Ben's point, actually, I was really dying to know whether there's a common foundation under the atrium and the living accommodation, or whether the atrium is actually essentially an uninsulated floor, and also whether there's any form of air conditioning, sorry, not air conditioning, but preconditioning of the MVHR intake with that kind of passively heated space. It would warm up the intake on the ventilation. I wondered if there was any integration with the MVHR that the modules clearly have. But that was my general take. It was hugely inspiring, but got some kind of technical questions about that atrium and the integration with the living accommodation.
Well, I think
Martin, as far as I remember, it's they weren't allowed to because of fire restrictions to use the air from the atrium garden.
No, we have to use air from the outside. That's true.
Yeah.
We have to use air from the outside because of the fire regulations. Yeah.
Yeah.
Sure. And is there a common foundation underneath the whole space, or is it sitting on a separate uninsulated ground floor?
It is sitting on an uninsulated ground floor.
Hand over to Zach now, because I saw a load of questions coming in. I know we're not going to have time for all of them, but let's see how many we do have time for.
Indeed, yeah. So we'll start with questions now, and then for folks who can stay after the top of the hour, we'll continue on. Lots of great questions. So the first one comes from Brian Thomas. So Brian, can you unmute yourself and ask your question? Actually, I don't know that you're still here.
I am still here, Zach.
Okay, yeah. Great. Brian, please fire away.
Thank you very much, Zach. Really enjoying the series. Just a very quick question from Martin. The sheltered housing, do you have to have, or have you supplied a guest room for each one of your, I suppose, guests or whatever you call them? The design reminds me of a modern day monastery, but I wonder, is there a guest room in each one of the apartments?
No, we only have one common guest room, and it houses up to 6 persons. So you have like 2 separate units where you can have a family of 4 and 2 in a single bedroom. So there's only like 6 extra spaces for guests.
Great, thank you, Brian. All right, next up is Alex Sawyer.
Hi, Martin. This question is for you, and it's an economics question. So looking at the design, you obviously have a much higher ratio of common space to sort of saleable, leasable space than what we would typically build here in the US. And so what I'm interested in is, how did you pay for that? I mean, are the units maybe a little higher than the typical market? Is it subsidized in some way? Are land costs just really cheap? Like, how does that work?
It's a golden combination. Where we build, we have the land cost at a minimum, first of all. And second of all, it's included in the rent. So the rent is, if you take the housing square meters, you pay a higher rent than market value. but you get an extra value from the common areas. The housing units, the small one are 55 square meters, and the bigger one are 77 square meters. So, and then you pay an extra like 25 square meters for the common garden, but we cannot price it as living area. So it's a very complicated calculation. But yeah, the rent is a bit higher than if you compare it to others just on the square meters.
And then, as you said, the land costs were also fairly low comparative to, I'm in DC, right? So our land costs tend to be pretty high. So that's what I was looking at. Okay, appreciate it. Thank you.
You're welcome.
Alex. Next up is Goran Molin.
Yes, hello. I'm working at the Exeter City Living, and we only build passive house to a passive house standard. So I wonder, can this be built to passive house standard? Have we been have problem to actually get this kind of courtyard solution to achieve passive house standard?
Can you answer that, Morten?
I'm not sure that the atrium is included in any energy frame calculation. Because it's considered as being outside, right, Martin?
Yeah.
So for sure, the dwellings can be built to passive house standards, I'm sure. As I also mentioned in the video, the more or less the whole flat roof is covered with PV, and this is also to yeah, more or less to reach the passive house level.
Great, thank you. Thanks, Goran. All right, next up is Tim Keating.
Hi, Zach, thanks. So my question has to do with CLT. I also, one of the other commenters said they didn't see any CLT in the presentations, but regardless, a lot of large timber beams and whatnot. My research, which I've been doing actually for the last 32 years, has shown that use of fast wood from fast wood plantations is actually not sustainable. So I'm wondering how, you know, in developing a so-called sustainable building, you know, you're using so much timber from, you know, what are basically tree farms, and thinking that's sustainable.
I guess I can answer part of it at least. Again, I'm not a part of the construction of the atrium garden, but of course I know things about the modules from FlexModul, and in general in Denmark, most of the timber is coming from Sweden and Finland. So for sure that is not fast growing. That's not fast growing timber. Of course, we also, like everyone else, gets our OSB and so on from other parts of the world. So I guess there could be an issue, but yeah, I'm not sure about it. That's what I can come up with. I don't know if you, Martin, do you know anything about the atrium garden?
Yeah, all the timber that we use comes from FSC certified forests.
Of course,
and I know that Sweden and Finland have a very strict policy on replantation. So, well, of course, we cannot build a 100% sustainable, but we can do the best that we can.
Fantastic, thank you. So the next question is going to be with Susan Jones, who is a luminary in design with CLT here in North America. But before we get to Susan, we're going to do some quick thank yous and kind of close out the first hour. So co-host, please take it away from here.
Yeah, so thanks everyone for joining, and thanks so much, Martin and Morten, for your time. And yeah, hope everyone was able to take something away from that. There's a lot to unpack. Thanks.
Yeah, thanks, Martin and Morten. And as I've already mentioned, co-housing, I think, has a lot of mileage. And the one thing that I would like to see is that quite often, well, the groups here in the UK take a long time to get right through a project. So that might be something we can investigate more after this particular show has been rounded off. Mike?
Yeah, thanks. Thanks again, guys. I'm looking forward to overtime because I know we've still got quite a few questions left. So I'll hand back to Zach to close out and carry on.
A big thank you to our sponsors: 475 High Performance Building Supply, Bax Ingwe Architects, Glavel Foam Glass Gravel, Miniterra All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. Our champion sponsors are Icon Windows and Doors, Proseco, and SIGA. And our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thanks to our patron sponsors, Aero Aggregates, Aero Barrier, Brennan, Brooklyn Solar Works, Euroline Windows, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood, Teasted. Get back to the questions and answers. Actually, before I do that, I want to thank the co-hosts for being part of Building Performance Interactive and their guidance in the conversation. A big thank you to the co-creators of Building Performance Interactive, Hugh Wieryski and Julia Potor of Partel. We're now on episode 6. We have 2 more episodes. This has been a great series, and just very thankful to Partel for making it happen. All right, so Susan, if you are still here, would you ask you had a number of questions, and I'm sure you can share some insights with us as well. Please, actually, I don't know if I see you anymore.
Sure, Zach.
Oh, good,
yeah.
Good, you're here, good.
Yeah, hi. Hey, thanks for the great program. And that's a really beautiful building, all of you who were involved. Thank you very much for sharing it with us. I actually had a really specific question, which is about modular construction and the down payment, which gets a little bit technical into the weeds. But in my experience in the US, a lot of the modular projects have been held up because there needs to be a rather large, often 50% of the construction cost paid as a down payment to the modular contractor, which is understandable completely. But I just wondered if you could share your experience in Denmark and what's typical, because it wreaks a little havoc on the typical construction loan drawdown system that's common in the US, but I'm sure it's different in Denmark. And my other question, I had a couple smaller ones as well, but my other question was somewhat related to the gentleman Tim Keating's question, but really, I was curious about if you had done an embodied carbon study or takeoffs or LCA study of the project. The modulars look awesome. And I'm happy to know there was Roxel, which looks like it has a pretty relatively low carbon footprint, but it looked like there was a lot of petroleum-based products in the installation. And I know that's always a common debate in Passive House, and it's one of the things that we're trying to address with biogenic carbon uses of things like mass timber and et cetera. But I'm sure you all have thought about these questions a lot, and I'd love your perspective. Thank you very much for a great project.
I'll do my best to answer these.
Do your best, Martin.
And I'm actually on my way in another meeting, so it'll be very quick. Regarding the down payment, we do have the same here in Denmark. We do it in a slightly different way. We don't have to make an actual payment. We make a contract and a letter of intent and saying if we order this and this, and then we pay on these and these and these and these dates. So we don't have to pay like 50% upfront. And on the Passive House standard and on the LCA analysis, we haven't done that yet, which is why when I market the project, I cannot call it sustainable. I can say that we have focus on sustainability, which we do have, and it's not a perfect zero emission project yet, but we are aiming to get there, which is one of the big advantages of making it in modules and as a concept, because we can develop all the time and use more and more eco-friendly materials. So we haven't made an LCA yet, but we are working on it. So I hope that answers your question. And I'm sorry, but I have to go now.
Cool. Thanks a lot. I have to go too. Bye-bye. Thanks, everybody.
Thanks. Patricia
Yeah,
from Western. Yeah.
Hi, my question is kind of related to Susan's a little bit. What I'm understanding is that the wood floor is part of the module that's pre-built. And then, so I'm wondering how that sits on the foundation. I'm assuming you have some kind of concrete foundation to a certain depth. Is there any, so there's no slab underneath the wood floor? If you could just tell me a little bit about that.
Yeah, I can answer that. I can't answer from the Ibihaven project because I am not sure how it was done back then, but the pictures I've showed you today is from Søndergaard. And this is this was a new thing for me, but I'll give you the best insight. The module is, as you saw it, it's done. So that's a complete wooden construction. On the building site in this next project, Søndergaard, there's not what you would see as a common concrete slab. There's actually only, I don't know the term, but lines or areas of concrete, of fiber concrete that is, and these lines are like 50 centimeters, and they would carry each half the module. This slab is only 15 centimeters thick. And then underneath it, you've got an XPS 500 SL, it's called. So it's very dense XPS insulation, but still with it's a class 0.34. Yeah, maybe you wouldn't believe it, but these 15 times 50 centimeters carry the free storage house. So you really don't have a lot of concrete in this project. Yeah. Zach?
Okay, great.
If I may, is that between?
Yeah.
Is that between the units or around the perimeter?
Only between the units. There's at the ends you don't have a foundation. I even think, Zach, if I can share again the PowerPoint, I think I can maybe I can show you. Just a second. Yeah, if you really look close, maybe I'll try this one first. So at these black lines, this is rubber product that is doing an let's say decoupling. But if you look at this picture, then you can see this is the total. This is 30 centimeters of XPS, but in these areas, these bit orange areas, they've got the 15 centimeters of this XPS 500 SL, and then 15 centimeters of fiber concrete. And that's all.
Okay, so next up is Mandy Broughton.
Hello, clearly I'm not Mandy Broughton, I'm her partner, Greg.
Hey, Greg.
Thank you for a very informative session. My question's about the PVs, that are they individually owned by each module, or is it more a community installation?
It is a community installation. Yeah. So it's yeah, a bit like you could see in the video. There's this screen where you can see the total production from the PV, and yeah, I don't know how it's calculated out on each apartment, but it's a common installation.
Okay, thank you. Yeah, we have had PVs described by one architect as builder's bling. So I think it makes more sense for it to be a community resource. Thank you.
I agree. You're welcome.
All right, thank you. So next up is Julia Bassett-Schwerin.
Hello, everyone. Thank you, Zach. I am a green broker from the state of Maine in the United States. Our state is over 90% forested, so I am, as you might imagine, very interested in cross-laminated timber. We've got several examples coming up in our state now, and I'm wondering, was this constructed with cross-laminated timber, and if so, where did it come from, and how did that process work? Were the pieces designed from the beginning to come out of the cross-laminated timber factory already designed to plug into these modules? Thank you.
Yeah, I'll take that one as well. This project is not CLT based, but other similar projects are. In Denmark, CLT is not so common yet, but we have an upgoing trend for sure. But the CLT would either be produced in Sweden or Austria. That's the current suppliers in Denmark are yeah, Swedish and from Austria.
All right, excellent. So next up is Philip Jordan.
Hello, I had a question about the fire and means of escape issues for the rather large, admirable, but very questionable communal area. You know, that you're very remote from a obvious means of escape when you're in the central areas. Some of them seem quite enclosed. So you've got to escape if there's a fire from an enclosed room in the middle of the communal area and get across and out of what could be quite a dangerous situation.
We do have a quite strict fire regulation in Denmark. So, and for sure, you won't be allowed to move into the building if you don't comply to the code. So I can see that it could be difficult to see it in the video and so on, but I guess you have at least 6 or 8 openings in the atrium. And again, this is not my area of expertise, but again, no matter what, you'd be close to your own apartment as well, and you've got fire escape from the other side in your apartment. So, but again, as said, strict regulation in Denmark that they'll have to comply with, or else they won't be able to take the building into use.
Good.
Yeah.
As you know, we had Grenfell here, and we've had a huge amount of work done by the government. They enlarged their means of escape part of the building regulations from about 20 or 25 staff to over 200 staff. And I've got a link to a video with the person who was in charge of it, who I think is quite incredulous of what happened. But it has happened.
Sure, I agree. I think that is, I guess that's not one of the reasons, but in Denmark, at least know regarding constructions when it comes to fire, then we have different pre-accepted solutions.
Yes.
You can either go with these solutions, or you'd have to get the specific construction evaluated by a fire inspector, and this is a very expensive part of
Yes.
of the building process for sure here in Denmark. So it's the easiest to go with accepted solutions.
Yeah, thank you.
You're welcome.
Great, thank you, Philip. Okay, I think we're to our last question here, but I just want to say that if I have missed your question, please don't hesitate to chat put it into chat right now, or if you have a final question that you want to add to the discussion, now's the time. So, but I think that our last question is from Darcy Dunal.
Yes, hi, thank you. Great presentation and a really neat project. I just one question I had was, can you achieve the same economies of using modules in a project with fewer units, say 6 units or something in that range?
I'm not sure, Darcy. I mean, the different prefab builders here in Denmark, they mainly focus on bigger projects. So I mean, if most of them also have some units they have for rental. So you could so if you have a smaller project, you mainly rent these for a couple of years or more. So I guess the answer is probably no.
Okay, thanks.
Yeah,
Thanks,
you're welcome.
Thanks, Darcy. All right, well, I think that wraps it up for us. Thank you very much, Morten, for fielding all those questions and for a great project and great presentation. Thanks also to Martin. I know that he had to leave at the top of the hour, but really inspiring work. Thank you also to Ben Adam Smith, Mike Jacobs, and Hugh Risky for being our co-hosts today, and Hugh and Julia Potor for creating the Building Performance Interactive. On behalf of Passive House Accelerator, it's great to see everybody here today, and I hope everyone has a wonderful Thursday, and everybody please be safe.